Hello everyone, this is Faisal Akawi. Welcome to this recording about the concept of Nat and Pat. By now you already know that for you to be able to take an EPC and get onto the internet, that PC must have a unique IP address. In today's technology, I have a family of five, and literally in my house there is at least I would say 10 to 15 devices between phones, between iPads, PCs, and computers. We have about 10 to 15 devices that requires an IP address. Of course, I cannot afford to have a unique dedicated IP address for each device. And because of the amount of devices that being on the internet, we are running out of IPv4. And for that reason, we went from IPv4 to IPv6, where we have technically unlimited number of IPs that we can use. Right now, the move is slow to change from IPv4 to IPv6 simply because of the concept of NAT and PAT. NAT, Network Address Translation, is a protocol that exists on the router, and what it does is it translates an IP address, a private IP address. As you already know, a private IP address cannot be used on the internet. It cannot leave the realm of your LAN. So you can use private IP addresses within your local area network. What NAT allows you to do allows you to translate a private IP address such as 192.168.1.5, let's say I have a PC with that, onto the network into a public IP address that can access the network. The translation for NAT is 1-to-1. So if I have another PC such as 192.168.1.6, if I have that second, I would need a second public IP address, 200.1.1.2, for example, in order to map that second private IP address to the network. So NAT did not solve the problem of the shortage of IP addresses, IPv4. But its cousin, we call it PAT for port address translation. It literally allows you to take one public IP address and map it to thousands of private IP addresses. Let's see how that is done. So let's look at this scenario where I have a private, think of it this way, where the red line to the left of my red line is a private IP address local area network. I'm using the private IP address 192.168.1.50 for one PC. I'm using .51 for PC2. And I was giving this public IP address 200.1.1.1. Let's say I have a server called IBM.com on the internet, and I have PC1 and PC2 both at the same time. They opened a browser and they typed IBM.com. Both machines did that right at the same time. And let's say we have the PAT configured and operating on this particular router. And so when you hit IBM.com and PC1, the operating system will generate a port number. Let's say it is 6700. As you already know, ports we have, we can choose any number between 1 and 65,535. We have actually that many ports we could pick from. So the operating system on the device 1 and PC1 will generate a random IP port number. Of course, it's not going to generate all the used port numbers will be excluded from this list, such as port 25, port 143, port 80 will be excluded from that pick. So let's say it generates 6700. The router will say, I have a public IP address, which is the 200.1.1.1. It will map the 67 port to it. It will translate. That's how we translate a private IP address into a public IP address. It sends the request out, comes to IBM, and then IBM would respond back to this particular IP address. And once the router receives the message on port, it looks at the port 6700, it says, now you must be going to 192.168.1.50. It will send the message to the particular device 50. Now, at the same time, let's say the scenario happened that two machines at the same time hit IBM.com. Of course, there's a switch over here. They're not going to reach the switch and the routers at the exact same time. They will take turn. And once the router will receive the request from the .51, let's say the operating system had picked the port 1500, and the router will do the same thing. It will take the 200.1.1.1 and map it to the 1500 port. It will send the request onto IBM. As far as IBM concerned, the request for that website came from two different addresses. It's not going to treat them as one. It will send a copy of the message back to the 192.168.1.51. While I showed the example of 50 and 51, literally I could have up to 192.168.1.250. So I could have 250 machines, and every single one of them will be mapped to the public IP address 200.1.1. And let's say this one, it will pick 6500. It will be mapped to 6500 port, and the same scenario happened. And that's the purpose of PAT. And because of PAT allows me to take an entire local area network, up to 250 devices in this particular case, since I'm using class C, and use one public IP address to serve every single machine on my local area network. Because of that, today people, they don't feel the need to jump onto IPv6 because the PAT technology concept has resolved the issue with running IP addresses, running out of IPv4 addresses. Before the concept of PAT, each machine on this local area network requires its own unique public IP address. One question might pop into your mind is, what if, since I'm picking up these port numbers randomly, what is the chance of two machines picking up the exact same port number? What if the first machine, .50, picks up 6700, and it happened right at the same time the second one picked the 6700? And let's say the first one hits the router will does the translation. It will translate the private with the 6700 into the public with the 6700. It gets the same request from 192.168.51, the second machine with 6700. And the router will say, wait a minute, the 6700 has been used, so the router on its own will pick the next number in line, which is 6701. It will send the message out. When the message comes back to 6701, it will translate it to 6700 and it will send it to that machine. So the PAT is intelligent enough to even discover when more than one device had picked the same port number. For those of you who are interested to see how the PAT works, since you are using, or you can use in your local area network, you could use a private IP address 192.168.5, for example, .1, .2, .3, which is a private IP address. You can do, you could run this show command, show IP NAT, I'm sorry, this is a NAT. Show IP NAT, well, this is a NAT translations, and that will be able to show you the table that I just showed you a minute ago with what is the IP address and the source, how it's translated onto the destination. PAT and the difference between PAT and NAT, that when you do NAT translate, it's a one-to-one transition. So for every private IP address, so let's call this a private IP address, it has to be mapped to one public IP address. So if I have 192.168.5.1, it will be mapped to 200.1.1.1. If I have the second one, which is 192.168.5.2, I'm going to need a second public IP address. And that's, again, that doesn't solve the problem. On the other hand, PAT allows you to map so many private IP addresses. So it's 192.168.5.1.2.3 into one public IP address, let's say 200.1.1.1, provided that you will add the port number. So let's say the port number is 111.1. It will map it to 1111. And the same IP address will be used for the second one, and the same thing for the third one. So the mapping will happen one to many IP address, and that's why PAT, again, solved the issue with running out of IPv4s. Thank you, and I hope you find this informative.